The year was 2000. Scientists were attempting to date what they believed was the oldest star in the universe, HD 14283, also known as Methuselah. They used the European Space Agency's Hipparcos satellite to estimate its age. What they found shocked the whole world. The star appeared to be 16 billion years old, challenging the age of the universe, which, according to the observations of the cosmic microwave background, is 13.8 billion years. How could a star be older than the universe itself? The star's age was evident from its composition. Being a metal core subgiant, it primarily consisted of hydrogen and helium with minimal iron content. This indicated that the star formed during a time when hydrogen and helium were prevalent in the universe, before iron and other heavier elements came to be abundant. These heavier elements are created in the cores of massive stars and were not as widespread during the star's formation. Could Methuselah be over 2 billion years older than the universe that surrounds it? Of course not. That would be impossible, but it did suggest that something was wrong. Either the dating was incorrect, or the universe is not as young as believed. Which one was it? The news of Methuselah spread like fire, and NASA realized that it could no longer delay a mystery of this magnitude. What followed was one of the most controversial speculations in the history of astrophysics, and it looks like the star has once again come into the limelight to rattle our understanding of the cosmos. But this time, it's not alone. Welcome to territory. This is your space. To unearth the mystery of the star older than the universe, astronomers turned to the most powerful eyes we had at that time, the Hubble Space Telescope. They examined 11 sets of observations recorded by Hubble's flying guidance sensors between 2003 and 2011. Hubble's observation showed that HD 14283 exhibited a higher than predicted oxygen to iron ratio. Since oxygen was not plentiful in the early universe for several million years, this finding suggested a younger age for the star. From 16 billion, the age of Methuselah dropped to 14.46 billion years. Significant, but still greater than the age of the universe. To counter this discrepancy, scientists proposed, or more like added, a residual uncertainty of 800 million years, aligning the star's age with that of the universe. But of course, it didn't sit very well with a lot of people because it seemed like a theoretical adjustment made to support the lambda-cold dark matter model. Additional refinements then reduced the estimated age of the star to 14.27 billion years, with a margin of error of approximately 700 to 800 million years. The star's age was now within 13.8 billion years, perfect for our cosmology. As years passed, Methuselah saw its age drop further before settling at 12 billion years. This is what is accepted as the star's age today, but a lot of scientists are still not convinced. At a July 2019 international conference of leading cosmologists at the Kavli Institute of Physics in Santa Barbara, astronomers were puzzled by conflicting studies suggesting different ages for the universe. Their focus was on observations of galaxies relatively close to us, indicating a universe younger by hundreds of millions of years, compared to the age calculated from the cosmic microwave background. Contrary to the 2013 estimate of 13.8 billion years by the European Point Space Telescope based on cosmic radiation measurements, the universe could be as young as 11.4 billion years. Furthermore, a 2019 study proposed a Hubble constant of 82.4, contrary to the known value of 69.8. This, too, put the universe's age at only 11.4 billion years. Fast forward to 2024, and today, with the powerful observations made by the James Webb Telescope, we have found galaxies that are 13 billion years old. So, the 11.4 billion year theory doesn't hold. Meanwhile, the same telescope's observations tell another story too. There might be several other stars like Methuselah, and they might be closer to home than we'd have imagined. This comes after a recent discovery of stars in the star cluster M92. It poses a significant challenge to the age of the universe. Brace yourselves, for here is a shocking discovery. A group of stars in the Milky Way appears to be as old as the universe. Or maybe older? Star cluster M92, a densely packed ball of stars roughly 27,000 light-years from Earth, is about 13.8 billion years old. The newly refined age estimate makes this clump of stars the same age as the universe. This could break the current age of the universe and put a new limit on it, thereby helping solve cosmic conundrums about how the universe evolved. The age is on the edge, as estimated by other groups, said astronomer Martin Meeing of Dartmouth College. It helps us set the lower bound of the age of the universe. We don't expect the star cluster to be born before the universe, right? Globular clusters, such as M92, consist of densely packed groups of stars believed to have formed simultaneously, simplifying the task of determining their ages for astronomers. Stars follow different life paths depending on their mass at birth. Larger stars burn through their fuel quickly and have shorter lifespans, while smaller stars endure for longer periods. Understanding how many stars in a cluster have transitioned beyond their primary fuel-burning phase provides insights into when the entire cluster originated. However, age estimations traditionally rely on assumptions about stellar evolution. Seeking a more reliable method, Ying and colleagues employed a computer to generate 20,000 synthetic stellar populations for M92, each representing a potential cluster age. They then compared the colors and brightness of each population with observations from the Hubble Space Telescope, determining the age that most closely matched the collected data. While M92's age has been measured before, previous estimates depended on a single synthetic star collection. By comparing thousands of synthetic populations, the researchers significantly reduced the uncertainty associated with assumptions inherent in each model. This novel technique resulted in a 50% reduction in the uncertainty of the cluster's age. The team determined that M92 is approximately 13.8 billion years old, with a margin of error of around 750 million years. Remarkably, this age aligns closely with the best estimate for the age of the universe, slightly over 13.8 billion years, with an error margin of approximately 24 million years. One way around that tension is to accept a different age for the universe, said cosmologist and study co-author Mike Boylan-Colchin of the University of Texas at Austin. If one takes the Hubble tension seriously, then one also has to say we don't know the age of the universe that well, he added. This discovery puts the lights back on the recently published University of Ottawa study that claims the universe is not 13.8 billion years old, but 26.7 billion years old. I have done a video on it, sharing the link in the description for you to watch. But to basically sum it up, the new model stresses the existence of stars like Methuselah, which appear older than the universe's estimated age, and the discovery of early galaxies with the James Webb Space Telescope. These early galaxies, observed only 300 million years after the Big Bang, exhibit levels of maturity and mass typically associated with billions of years of cosmic evolution, presenting a significant puzzle. But advancements in computing, theoretical understanding, precise measurements of cluster distances such as M92, and finding primordial galaxies at the dark ages justify a renewed approach. What do you guys have to say? Is the universe older than 13.8 billion years?